Hello everyone. Here is the test number 3 practice review video. We're gonna start this practice review with the first problem where they ask me to factor out the greatest common factor from the following polynomial. So first we want to find the greatest common factor, GCF, which is the largest factor that all the terms of this expression share. So we're going to start with the coefficient of this GCF. I'm looking at this expression, right? I see 8, 32, and 56 are the coefficients of the terms. And when you see, when you check, you can see that 8 is the largest common factor for these coefficients. So 8 is going to be the largest, the coefficient of the GCF. And then we take it with the variables, in this case, just one variable, which is x, with the least exponent. Least exponent here, 4, 3, and 2. The least exponent of all three will be 2. So x to the second power will be the variable with the exponent 2 for the GCF. Now that I have the GCF, I can write it outside of a pair of parentheses where I'm going to find out what to multiply this expression 8x squared by in order to find the terms that go inside. But we need to make sure that since we had a 3-term polynomial, the inside expression will be still a 3-term polynomial. So what do we multiply by 8x squared to get 8x to the 4th? We need x to the power. We need x to the power 2. Or you can say, oh, let me divide the first term by the GCF, 8 to the power 2. So what I got left is x to the second. So that's x to the second. I'm not going to leave it there. It's just the work I'm doing so I can find the result. And then we do the same thing here. Divide by 8 to the second power. So 32 divided by 8 is 4, so -4. And then subtract the exponent. 3 minus 2 is 1, so x. So that's x, 4x to the -4x. And then we're going to work with the last term. We divide by 8x to the second power. X to the second power on top, x to the second power in denominator. So we don't have an x power 0, so that's 1. And then 56 divided by 8 is 7. So that is a +7. And then if you check, you would see that the expression inside of the parentheses cannot be factored. There will be no 2 factors of 7 that add up to -4. That's when you would know that this inside expression, this inside trinomial, is called a prime trinomial. It's a prime trinomial, so you can't factor it in any further. The next problem here, so that's pretty much your answer for question number 1. The next problem, GCF is the binomial x plus 1. As you can see, it repeats throughout the expression for each group. So I can factor the GCF, I can factor it out as x plus 1 out, and then open another pair of parentheses to put the remaining factors. 9 plus 2a. Over here, they want me to factor by grouping. Factor by grouping. So we group the first two terms and the last two terms. From the first group, the GCF is A, factor it out. And then for the first term, we got B left when we factor A out. And the second term, we got 6 left. We will factor the GCF also from the second group. GCF is 3 plus 3 out. And then B left when we factor 3 out from the first term of the second group. And then divide 18 by 3 that is on the outside. It's plus 6. And then we can do the same thing we did in the previous problem. Factor this binomial B plus 6 out. So that's B plus 6 out. And then A plus 3 for the second pair of parentheses that completes the factored form of this expression. We will do the same thing for number 4. We group it and then find out what to factor out from each group. The first group here, we can factor out x squared. So that's x minus 1. Factor out -7. And that is x minus 1. And then we will factor x minus 1 out as a group GCF. And then x squared minus 7. So because 7 is not a perfect square, I don't want to use the difference of squares in this case. So that's going to be my answer for this factored form, for the factored form of this expression. Number 5, do the same thing, factor by grouping. I will group him by 2 terms. GCF of the first group will be A. When I factor A out, left C plus 5. And then the second group, I factor -3 out. C plus 5 will be left to be put inside of the parentheses. And then now we factor the C plus 5. And then A minus 3 will be the second factor. This case here, sometimes, mostly when you see a number that is not equal 1 as the coefficient of x squared when you have a trinomial of second degree, you want to check to see if this number is not the GCF of the expression. If it is, then you factor it out, factor the GCF out, 7, and then write your monic expression as x squared minus 3x plus 2. And then since you have a monic trinomial with a equals 1, you can set up your answer with the GCF still outside, set up your expression, draw your answer as two pairs of parentheses, and x squared is broken down as x for each parentheses, and then find 2 factors of the constant, that the sum is the coefficient of the linear term, which is the x term in this case. So the 2 factors of 2 that add up to -3 are -1 and -2. -1 times -2 is +2, and -1 minus 2 is -3. So we have these 2 factors. We just complete the parentheses with them, and that completes the factored form of this. But be careful, you cannot do that, just that. You cannot do just that when a is not equal 1. So don't do it. Please don't do it. Don't do just that when a not equal 1. I'm talking about when the coefficient of when the coefficient of x squared is not 1. You cannot do that. We will see what to do in number 7 though. 2 ways you can do it when the coefficient is not equal 1. So in this case, I'm going to check to see if 4 is the GCF of this expression. It's not. It's not. So then we're going to have to apply the second rule to multiply A and 9. That's a 36. We can have it two ways. I'm going to show you both ways. So 36. We break it down into two factors that the sum is negative 13. The sum should be negative 13. So what are the two numbers that you multiply? What are the two numbers you multiply by? Sorry, I need to fix this. Sorry. What are the two numbers you multiply by to get 36 and add to 13? Negative 13. Obviously, these two numbers will be negative 9 and negative 4. Negative 9 and negative 4. So I'm doing it two ways. So you can see, you can pick your own way to do it. And I think these two ways are not the only ones. If you know a way that you can do it that is, you can demonstrate, you can do it that way too. There's no limit in ways you can do a math problem, because you can have your own way and do it as long as you can demonstrate your steps. Okay, so here, first one, you can do it by grouping. We come here with the two factors here. We break the middle term down as negative 4x minus 9x, which is still negative 13x, and then plus 9, drop down, and then drop the 4x squared down. Now you have four terms. We just group and factor. So that is 4x out, x minus 1, and then negative 9 out, x minus 1, and then we factor the x minus 1, so 4x minus 9 is the factored form of this. Or you can just divide the coefficient, the two factors of this product of A and C. The two numbers you found that summed to negative 13, you can just divide them by the value A, which is 4 in this case, and then set up your parentheses just like you did earlier when you had a monic trinomial. When you have a monic trinomial, and set up the x for each parenthesis. The first fraction, the bottom goes with the x, and then since you have a negative 9 on the side. And then the second one simplifies to negative 1. So if you want to see it as 1 over 1, and then it's going to be 1x, which you don't even have to put, and then minus 1. So if you want to go either way, it's fine, totally fine with me, the way you do it, as long as you can demonstrate the steps. So, and then that's your factored form. Two ways I did it, and you pick one to do it on your way on your test, or you can keep both ways and feel free to do either one. Number 8. Number 8, we will try to look for the GCF, if any. I think 3 is the GCF. 3x is the GCF in this case. Factor 3x out. So I have 3x out. So that's 3x squared plus 8x, and then plus 63 divided by 61 is 21. So now we're gonna see how we can multiply and then factor the GCF, right? So what we do in this case is that we're going to multiply. We're going to multiply 3 and 21. And then we get 63. We need two factors of 63 that the sum is 21. Is 8, that the sum will be 8. Now we know that it's likely not to be possible, because how would you have two factors of, but you can always check for the other factors, but it's clear that you will never have factors of this that the sum is 8. So then this expression inside of the parentheses will be a prime trinomial, which means you can't factor it any further. But you need to make sure that you check for all the possibilities before you assume that it's you don't have to show me that you check, but the worst case would be you say that it's prime while it wasn't prime. Okay. And then next problem here, we multiply 4 and -20, because 4 is not the GCF, so we want to multiply, or we don't have a GCF that is not 1. GCF is 1, so we can multiply 4 and -21. So that is 4 and -21 is -84. And then two factors of -84 that the sum is 25 are -3 and 28. Of course, you're gonna spend some time to search before you see it, and then you can have the right two pair of factors to break it down. So then that I have this, I can write it as 4x squared minus plus 28x minus 3x minus 21, and factor by grouping 4x out. So that is x plus 7, -3 out, still x plus 7. And then x plus 7 factored out again, and then 4x minus 3 would be your factored form. We want to factor this, two factors of, so basically since it's a monic trinomial, coefficient of x squared is 1, set up your parentheses and break your x into two factors, because when it's squared, it's like each parentheses have one of the x's that would multiply to give you the square. So that's how you predict your answer. And then now two numbers that multiply to give you -82 and add to -39 are what? That is 2 and 41 negative. So that's +2 and -41. That's the completely factored form of your expression. Now we want to go to the next problem. Number 11. Number 11, look at this and find out what to do in order to factor it, because the difference here is that you have the variable in both sides, in both ends of this expression, which would mean that you're going to have to make sure that it includes the same variables that are squared at the end of at the beginning and end of the expressions, or the expression are most likely going to be the same variables that you see. You're not going to see one variable in the middle term. So that's why you have x, y. Now, how do you factor this? I would advise in this case that you use the group factoring method. So you can see the steps of what you're doing. That doesn't mean that you cannot do otherwise, but I would advise that you do it so you can understand the steps that you're making. So first, we multiply the coefficient of the square terms. So that is 50. And the 50 now, we're going to break it in two factors, that the sum is -15. -10 and -5 will be the two factors. So then now you can separate the -15xy as -10xy and -5xy, and drop the terms, that the end and start terms. So plus 2y squared and 25x squared. And then now we have four terms, we can just group them. Factor the GCF of each group. So that's 5 for this one, 5x actually for the first group, two terms. And that's 5x minus 2y. And then the second group, just y is the GCF, -y goes out, and then 5x minus 2y, and factor out 5x minus 2y again, and then complete your factored form as 5x minus y for the second pair of parentheses. Now you see how you see all the steps when you use the group factoring. All right, so over here, you have two choices. You can do exactly what we did in number 11, or you can do use the special, one of the special products that we learned in class. So this one is a minus b squared, which is the form that we want for this, but we know that this is also expanded as a squared minus 2 times ab, and then plus b squared. So now we need to make sure we identify the a squared and the b squared from the expression that we get, and make sure that with that we can evaluate after we get a and b to see if it equals to the product of -2 and the a and the b, if it gives me -40. So first, let's try to identify a and b and square them. So that equals, so we want to find the a and b that we need to square. What do we square to get 25a squared? Your answer should be 5a. And then what do we square to get 16? Your answer clearly must be 4. And then now we want to follow this pattern here to write the middle term without looking at the whether it's 40 or not. We don't want to deal with it yet. Okay, we will verify it after since we have the first term that's squared and the last term that's squared. Now we want to write it as -2 according to the formula, -2 times the first number. So that's the expression 5a, and then the second, which is in this case the 4. Okay, and then now we want to evaluate this to see if it equals -40a. Yes, it is -40a. -40a. So that checks. Then we can write this expression as this formula because it verifies the middle term after we write it. And then now we can go back to our final steps, which is that equals the square on the outside, which is this. What we considered as a was 5a here, and then the negative sign, and then the b is 4. So that completes the steps to factor this using the special factor formula. Or you can use factor by grouping just like we did in number 11 as well. But I wanted to give you different options as you're working and trying to see which one you would prefer to work with. And then number 13, though, you can do the same thing, or you can factor by grouping. It's your choice. But I'm gonna do this one by grouping. But first, let's see if we can find a GCF that is different from 1. When I'm looking throughout the expression, I see that the GCF here is x squared. Then let's factor it out. So x squared pulled out. So that's 9y squared plus 24y, and then plus 16, with the x squared being on the outside. So when you do by grouping, there's a precaution that you need to take, which is after you do the steps, you sometimes forget to apply the GCF that you pulled out with your expression. So I am being cautious to drop it down so I would not forget it when I finish the steps of factor by grouping. So let me work now with the expression in parentheses to factor it by grouping. So when factor by grouping, you remember we need to find out what is the expression, what is the number to multiply by. I mean, you should multiply the coefficient of the squares at the beginning, at the end, or we also can multiply the coefficient of the squared term by the constant. Depends on whether you have multiple variables in your trinomial. So in this case, we have a, b, c. We can multiply a and c. 9 and 16. 9 times 16 equals 9 times 16 equals, let's do it here, 9 times 16 that equals 144. That equals 144. And then we need two numbers to multiply to equals that equals 144 and add to 24. So easy, 12 and 12. And then we come here, we write the expression as 9y squared, the first term, plus 12xy, 12y, plus another 12y, which would complete the 24y because I need 4 terms, and then plus 16. Factor the GCF of each group, first group, second group. So the GCF of the first group will be 3y, and then we factor it out as 3y plus 4, and then the second group, the GCF will be 4 plus 4, factor it out, so that's 3y plus 4 again, and then we factor completely to get the final expression, 3y plus 4, factor 3y plus 4, and then so then that we have 3y plus 4 repeats. Your final answer here is, you can write it as a condensed expression with the square because it complete. They said factor, but we want to factor completely. So that's x squared factor 3y plus 4 squared. So that's the completely factored form of this expression. And in number 14, we will think about one of the special factors that we learned in class. But before that, we need to check to see if there is a GCF to factor out, which I feel like we have one. So GCF GCF equals y. We want to factor y out, the y factored out. Actually, GCF is 6y. 6y. So 6y factored out. And then we have 4x squared minus 1. We're not done yet. One other thing we can use is a difference of squares. Difference of squares. If you have two squares and you subtract two squares, we can factor it as subtraction of two squares. It's not the sum of two squares, only the difference of two squares. It factored as the difference of the numbers that were squared and their sum. So the product of the difference and the square, the sum of two numbers is also the difference of their squares. So now, if we have 4x squared minus 1, it's like 2x squared, 2x in parentheses squared, minus 1 squared. And if we apply this, it'll be the 2x minus 1 and the 2x plus 1, which is the completely factored form of a of 4x squared minus 1. So we have that here. So then completely factored form of this expression is 6y factor 2x minus 1 times 2x plus 1. And then the next problem is pretty much the same process. Identify and then factor using the difference of squares that we have up here. Difference of squares is so first let's identify the squares. 7 is what you square to get 49. So 7a squared minus 25 is the number to square to get 5 is the number to square to get 25. So that is 5 squared. So we have the two numbers we square to get the expression. So we can apply the difference of squares here. So 7a minus 5, 7a plus 5 is the factored form of 49a squared minus 25. And we can even use it if we have a difference of terms in fourth power. Well, we want to identify this because what happens is sometimes we can raise power to power. And when we have that, we can also use difference of squares. So for this one, we can have s squared squared, and then that can minus 25 squares, which is the square root of 625 is 25. But because 25 is also 5 squared, then we can write it this way too. So that can be 5 squares, 5 squared squared. So we're going to do this formula probably double in order to find the completely factored form of this expression. So let's check this out. So first, we want to use it once. So that's s squared minus 5 squared, right? Times s squared plus 5 squared. Since it's not going to be a difference, I know this one will not be factored. So I can just put the 25 instead of just 5 squared. So 25, which is 5 squared. But this one, I keep it because I know later on, I will want to factor this again because it's a difference of squares again. So if we refactor that, it's going to be s minus 5, s plus 5, and then the other factor, s squared plus 25, which we cannot factor using difference of squares because it's not a difference. Next problem here, we can factor the GCF. I'm looking at some type of GCF, and then after that, we will see what we do. But I have the impression that this will be one of another of our special factors that we learned in class. So let's factor the GCF, which is y to the 5th power. And then when we factor it out, it's 64 minus x to the 3rd. Now I have 64, that when you take the cube root of 64, or what do you cube to get 64? All of you would know that is 4. So that I know that 64 is 4 cubed. (64) is 4 cubed. So my expression is y to the 5th power times 4 cubed minus x cubed. And then the formula for the difference of cubes is a cubed minus b cubed equals a minus b factor a squared plus ab plus ab plus b cubed, b squared, sorry. And then now that we can apply this with the a equals 4 and the b equals x, that would be 4 minus x, not x minus 4, by the way. And then 4 squared is 16 plus 4 times x, 4x, and then plus x squared. So that is going to be the expression to get from the factored form of 4 to the 3rd minus x to the 3rd. Now bring it here, and then with the GCF y to the 5th, that's the answer factored form of this expression. That's the completely factored form. And also we can apply the cube root, the sum of cubes as well, which is after we factor the GCF, if any. Over here we don't have a GCF, we can just straight apply the sum of cubes. That is a cubed plus b cubed equals a plus b factor a squared minus ab plus b squared. So let's identify the cubes first before we know what's going on here. So that is 2x, we cube to get 8x cubed, plus 5y that we cube to get 125 y cubed. Now, if we have that, then we can replace a by 2x and then b by 5y in this formula. So we will see what would be this expression here in factored form, cubed. And then now the first set of parentheses has the 2 base of the exponents. So that is 2x plus 5y. And then the second set of parentheses where we put first the first base squared. So that's 4x squared. And we multiply the 2 base. So that's 2x times 5y. So that's 10y, but it's a minus sign, 10y xy. And then the square of the second base, which is 25 plus 25 y squared. So that is the factored form of the expression that we have here when we apply the sum of cubes. Okay, and then now we're going to start solving, use factoring to solve equations. We're going to use factoring to solve equations. So let's see here how we solve by factoring. Number 19. When we solve by factoring, we should use, if you remember, the zero product property. Now, if we have a product, A times B times C, or more factors, but in factored form, right? A times B times C times D times a number of factors, and all the product is set to 0, it's at least one of them that is 0. I said at least one of them. When I say at least, it may be all of them equals 0, but at least one of them must be 0. So that's why when solving this, you need to assume you check all of them to make sure that you check all the possibilities for these factors to be 0. It's A equals 0, or the B equals 0, or the C equals 0. Now, it gives you the opportunity to explore all the possibilities for this expression, product expression, to be 0. And then now you can find the possibilities for this expression to be 0. And then that's going to be the set of your solution. But two things are important, because this is called the zero product rule. The zero product rule, it means that you need a factored form of your expression on one side and a 0 on the other side. So that means my equation should be on one side a factored expression, and then on the other side a 0. Then that's when I can use the zero product rule. It's a zero product rule. If it's not 0 on one side and the product on the other side, you can't use the rule. So that's what it means. So that's why we gathered all these tools about factoring, so you guys have no excuses to factor an expression in order to solve an equation. So let's start here. How do you factor this so you can have the product equals 0 to use the zero product rule? So set up this, because the coefficient of the squared term is 1. We have a monic trinomial. So that's going to go as C for each parenthesis, and find two factors of 40 that the sum is 13. What are two factors of 40 that the sum is 13? I feel like it's going to be 5 and 8. 5 times 8 is 40. And then add 5 and 8 is 13. So that makes it easy for me to complete my parentheses with the 5 and the 8. It does not matter which one you put first. And then go now apply your zero product rule. So that is C plus 5 equals 0, or C plus 8 equals 0. If I had more factors in my expression, then I would set them each equals 0. And then solve each. So minus 5 on both sides here. C equals -5 for the first one. And then we have minus 8 on both sides here. We got C equals -8. And you have your solution that is -5 and -8, which are the possibilities, all the possibilities for this expression to be 0. And in the next example here, number 20, we can multiply, because the coefficient of the squared term is not 1. So we want to multiply. And then that is going to be -45. We need two factors of -45 that the sum is 4. So it's going to be 9 and -5. So now we can factor by grouping or divide each by the coefficient of x squared. And now this one can simplify to just 3 or 3/1. So we're going to use it as, I set this up for this case. And then the bottom goes with the variable. So that's 1x, just x plus 3. And the bottom goes with the variable x, 3x minus 5. Okay, and now I have my factored form. Also, you could use the factor by grouping as well. Don't forget that too. And then now I use the zero product rule, x plus 3 equals 0, or 3x minus 5 equals 0. We subtract 3 on both sides. Here, x equals -3. And we add 5 on both sides. 3x equals 5, divide by 3. X equals 5/3, which gives me my set of solution, -3 and 5/3. Now, when you solve, you will not forget that we can use the zero product property, and the zero product property would be 1 0 on one side and a factored form on the other side. So let's subtract everything on one side to move it to the other side. But here I always like to move the term. If we have a term that the highest exponent term, I always want to keep it home. So that's why I subtract this side, the right side, from both sides. And then I want to write my expression in standard form, which is keep the expression in descending order of exponent. So x squared minus 11, and z squared minus 11z, and then plus 18 equals 0. Since the coefficient of the squared term is 1, so I can set up the parentheses, find two factors of the constant that summed to the linear term coefficient. In this case, -9 and -2. So z minus 9, z minus 2, and set them each to 0. Z minus 9 equals 0, or z minus 2 equals 0. Add 9 on both sides for the first one. Add 2 on both sides for the second one. Z equals 9, or z equals 2. Your solution, 9, 2. Well, I always say whenever you have fractions, you want to find the least common denominator to multiply by. In this case, you all know we multiply by 10. And that takes me to the new problem. 8t squared equals 6t plus 27. And then I want to keep the highest exponent term on one side and then move all the terms. Well, some of you may feel it easy to move one term, but I feel it more comfortable for me to keep the term with the highest exponent, the leading term, on fixed, and then move the other terms. So you do whatever you feel comfortable with. But I feel more comfortable to keep the leading term lead. I let the leading term lead. Okay, so that means it's 8t squared when I subtract the other terms on the other side, minus 6t minus 27 equals 0. Check to see if there is a GCF that you can factor out or divide by if it's not a variable. So in this case, it's GCF is 1, so I want to multiply 8 and 27 to have, and negative 27. 8 and negative 27. 8 and negative 27 So what 8 times negative 27 equals 8 times negative 27, 8 times 27, it's negative 216. And then now we need two factors of this. We want to play with the numbers. The two factors of negative 216, that the sum would be 6, or negative 12 and 18. Negative 12 and 18. But since we want negative 6, though, it's negative 16, negative 18, and positive 12. And then you can factor by grouping, or you can divide by the coefficient of a, the a term, and then simplify. For this one, when you simplify, what do you get? Simplify by 4, so that is 3 over 2. And this one, when you simplify by, we want to simplify by 2, so that's negative 9 over 4. So the factored form here will be, the bottom is the coefficient of the variable in the set of parentheses, so 2t plus 3, and the bottom for the second fraction will be the coefficient of t in the second factor, so 4t minus 9 equals 0. And then solve each of them equals 0. So we will have 2t plus 3 equals 0, or 4t minus 9 equals 0. And then we can subtract 3 on both sides and divide by 2. So t equals negative 3 over 2. So add 9 on both sides and divide by 4. T equals 9 over 4. Your solution set is negative 3 over 2, 9 over 4. Our next problem is the same thing that we've been doing: zero the equation out, factor, and use the zero product property. Zero the equation out, set zero your equation out, factor, use the zero product rule. All right, so let's zero out by subtracting 81y. So that's y to the third minus 81y equals 0. Factor the GCF. Y squared minus 81 equals 0. Use the difference of squares. Y factor y minus 9, y plus 9 equals 0. Use the zero product property. So that's y equals 0, or y minus 9 equals 0, or y plus 9 equals 0. Equals 0. And then now we solve each. This one's already y equals 0. We have it. And then y equals 9 for this one, and y equals -9. So your solution is 0, 9, -9. Same thing, same steps here. Zero out. Let's subtract subtract 9n squared and add 9. And then we have n squared, we put it in standard form, n cubed minus 9n squared minus n plus 9 equals 0. Factor by grouping, n squared factor n minus 9 minus 1, n minus 9 equals 0. N minus 9 times n squared minus 1 equals 0. Use the difference of squares to factor again. N minus 9, n minus 1, n minus 1 plus 1 equals 0. And then n equals 9, or n equals 1 from the second factor, or n equals -1. Your solution is 9, 1, -1. When you have a factor that repeats for an equation, not when you factor. If it's an equation, you have a common factor that repeats that is not a variable. If it includes a variable, you can't divide by it. You can only divide if the common factor is a constant, a number. So in this case, I can divide by 3 and then get 10x plus 9 plus 3x, 10x squared plus 3x minus 1 equals 0. Two factors multiply 10 and -1, that's -10. Two factors of -10 that add up to 3, that's -2 and 5. And then divide by 10, you would have two factors. You can simplify this as -1 over 5, and then this one simplifies to 1 over 2. And then the factored form here would be denominators go with the x, 5x minus 1, and then 2x plus 1. And then set each 5x minus 1 equals 0, or 2x plus 1 equals 0. And then go ahead and solve each of these equations. So you got subtract, add 1 for the first one, 5x equals 1, divide by 5, x equals 5, 1 over 5. And then the second one, subtract 1, you got 2x equals -1, divide by 2, you get x equals -1/2. So your solution, 1/2, your solution set 1/2, 1/5, and then -1/2. Let's solve these two problems here. So we want to zero out, right? So x squared minus 3x minus 10 equals 0. Two numbers to multiply to get negative 10, and to add to 3, or 2 and negative 5, and then monic trinomial. So just break down the x minus 5, x plus 2 equals 0, and then solve each x minus 5 equals 0, or x plus 2 equals 0. Subtract, add 5 on both sides, x equals 5. Subtract 2 on both sides, x equals negative 2. Your solution set 5, negative 2. Over here, though, we want to solve this by subtract 0 out first, 72r, and then get 2r cubed plus 10r squared minus 72r equals 0. GCF now is, but since we have 2 in all the factors, we can divide by 2. You cannot divide by 2r, but you can divide by 2. And then that gives you this new problem here, r to the third plus 5r squared minus 72 equals 0, 72r. Then we factor r out. So that's r squared plus 5r, and then minus 72 equals 0. Now we need two numbers that can multiply to give me 72, and subtract to 5, or add to 5, by the way. So what are these two numbers? These two numbers, oh, actually I divided so it's not 72, it's 36. Okay, so 36. I'm sorry, I missed this step here, but yes. And then now two numbers multiply to negative 36, and then add to 5 are 9 and negative 4. So the factored form completely will be, so r plus 9, r minus 4. And then we go ahead and solve each factor separately equals 0. And then so this one is 0, so this one will be r equals negative 9, and this one will be r equals 4, and your solution set is 0, negative 9, and 4. So this is problem number 7, and in the next video we will go over the remaining problems.